Hello and welcome to Python Programming for Beginners Part 2. In this video, we will dive into the exciting world of control flow, where you will learn how to make decisions and repeat actions in your programs using if statements, for loops and while loops. We will be exploring this concept through Karel the robot, giving you a hands-on way to see how control flow works in action. Let me tell you a little about myself. My name is Devraj Agarwal. I am an experienced software professional with 25 years of expertise in building and managing applications across consulting, finance and various other industries. If you are looking to dive deeper and learn the complete fundamentals of Python, I recommend checking out my Python's beginners course on Udemy. This course offers easy to follow lessons along with quizzes, exercises and solutions to help reinforce your learning. The course link is shown here and in the video description below. If you have not watched part 1 yet, I highly recommend checking it out first. Link for part 1 is in the description. In part 1, we introduced Karel the robot, explained what it is, the commands it can follow, and how to set up the programming environment. It's the perfect starting point before diving into control flow. Here is a quick introduction from part 1. Karel the robot is a simple robot that lives in a grid-like world. In Karel's world, there are 4 basic directions: north, south, east and west. Karel can move one step at a time in any of these directions, but it can't walk through walls. Walls are barriers that Karel must navigate around. In addition to walls, there are objects called beepers, which Karel can pick up and put down. Karel knows just 4 basic commands: move, turn left, pick beeper and put beeper. Using these simple commands, you will learn how to control Karel and solve problems within its world. Control flow in programming refers to the order in which individual statements, instructions or function calls are executed. It's all about directing the program's decision-making process through constructs like loops, conditional statements and functions, allowing the program to respond differently based on specific conditions. Understanding control flow is key to writing dynamic and responsive code. It makes your program flexible and dynamic. The 3 control statements in programming are if statements, for loops and while loops. The if statement executes a block of code based on a condition. The for loop executes a block of code a set number of times. The while loop executes a block of code indefinitely until a condition is true. The if statement is used to execute a block of code only if a specified condition evaluates to true. Here is the basic syntax and an example. In this example, if beepers present, so beepers present is the condition which is checked. If it's true, then the code block which has the command pick beeper will be executed. The for loop iterates over a sequence such as a list, tuple, string or range and executes the block of code for each item in the sequence. We use the for loop when we know exactly the number of times we want the code block to be executed. In the example here, we are using the range function that returns a sequence of numbers from 0 to 4. The for loop iterates over this range of values and executes the move command 5 times. We use the while loop when we don't know the number of times the code block has to be executed, but only know that the code has to be executed repeatedly until certain condition is true. In the example here, we are testing the Karel function front is clear, which returns the boolean value true or false. If it returns true, the move command will be executed. If the function returns false, Python will exit the while loop. We now know the basic foundations of managing a Python program using conditions. Let's revisit the example from part 1, where we placed a beeper in the southeast corner. In this task, Karel moved to the southeast corner, put down a beeper and then returned home. Let's explore how we can improve this solution with our newly acquired understanding of conditional statements and loops. We are now in PyCharm. I have created a new Python file beeper1se version 2 solution and copied the source code from the solution we had implemented in part 1. When we run the program using the run icon, it loads the start state, a world with 6 rows and 5 columns. Let's click the run button to execute the main program. It works as expected. Now we will try to improve this program using the control flow. In step 1, Karel moves to the other corner. we know that Karel has to move 5 times. When we know with certainty, what kind of control flow can we use to replace the code that we are repeating 5 times? If you suggested for loop, you are right. Let's replace the code with for loop. So we go to this function, we comment out the code, and then we write the for loop. In this code, we are using a for loop which helps us repeat an action multiple times. The range function, as explained earlier, generates a sequence of numbers starting from 0 and going up to 4, which gives us 5 numbers in total: 0, 1, 2, 3 and 4. Inside the loop, we call the move function. This will make Karel move 5 times. Let's run it again. It works as before. Now we are going to change the world from 6 by 5 to say 5 by 5. So we load the 5 by 5 world and run the program again. Well, Karel crashed into the wall. What went wrong? In the program, even though we are using the for statement, we are expecting a 6 by 5 world. When the world is changed to 5 by 5, the definite condition required for the for loop is no longer true. So how can we code to accommodate the program to a world of any size? Now the number of times the move command has to be executed is not certain anymore. In this indefinite scenario, we need to use the while loop. But the while statement requires a condition to be tested. Here we would like to move only if there is nothing in the front. If the front is blocked, we don't want Karel to move. In Karel's reference document, you can find one such conditional function. Front is clear, which will return true if front is not blocked. On the last corner, front is blocked, so the condition will become false and the program will exit the while loop. Let's replace the for loop with the while loop using the front is clear condition. Let's run it again. The program runs with the 5 by 5 world. Now load worlds of different sizes and run the program. So the program works with all cases. You can see how important it is to understand the problem and use the right code type. In this task, we have a world with 7 rows and 7 columns. There are beepers on some corners of the first row. Karel needs to build a column of 5 beepers wherever it finds a beeper. In PyCharm, we have a new Python file with code to load the initial state. The file name is build beeper column solution, and here we are loading the initial state build beeper columns start world, which has 4 beepers on corners. The task is that in the 7 by 7 world, we have 0 or 1 beeper on each corner. If a beeper is present, create a column of 5 beepers on that corner. After completing the task, Karel should return home and face east. You can find these worlds and the solution in my GitHub repository. So let's decompose the problem first. Our first task is to move across the first row. The second task is to build a column on the last corner, and finally return home. So to move across the first row, so the condition we have to test is as long as the front is clear, Karel can keep moving. So it can be a world of any size. We are using the while loop, and the condition is while front is clear, move. You can run the program. So Karel goes all the way to the end. The second task is to build a column if a beeper is present. We have to do this task while Karel is moving to the other corner. So let's take this one and put this code inside the while loop. So, the first thing we have to check if a beeper is present on a corner, and for that we have a function available to us, beepers present. What we have to write is, if a beeper is present, then build a column. Okay, so it's perfect for applying the if condition. If beepers present, let's write build a column. So how are we going to build a column? So the first thing Karel has to do is to turn left. Okay. Now after turning left, Karel is still on the same corner. It should not be putting another beeper there. So it has to move forward, and then it should put a beeper. Now here Karel needs to cover 4 more corners. So we do move and then put beeper. We do one more move, put beeper, and then finally the 4th one we do move and put beeper. Let's run the program. Karel put the beeper on the 5 corners here, but it went all the way up to the front. Now if you see in the code here, we use the if beepers present, we put 4 more beepers there, and then we are out of the if condition, but the while loop is still running, and while as long as the front is clear, the move command makes Karel move forward. So what we have to do is, after Karel puts the beeper, it needs to turn back. So after the 4th beeper is placed, Karel needs to turn back. So we have a function called turnaround. Then Karel needs to move all the way to the front. Now we know we have already used the while condition, so we can reuse that. You can, since we have to put 5 beepers, you can use the for condition also, but let's use the while. So while front is clear, move. Let's run it again. So now we crashed. Now what's the reason for crashing? Karel is facing down. In the if condition we exited the loop, we did not crash here. Okay. If you look at the code, it crashed at line 32, which is here. So in this while condition, since the front is not clear here, so we exit the while loop, but in the outer while loop we are still using the move command. After this move is executed, then we will be testing if the front is clear. So it is you have to be very careful that this condition is not continuously tested. Once this condition is tested, the code will be executed until the whole code block is complete, and then you go back to the testing the condition for the while loop. What we have to do here is to, after Karel comes down on the last part, we need to make Karel turn left. So here outside the while loop we turn left. So reset, run program. We have successfully completed building 3 columns. Why did Karel did not build the 4th column? So what exactly is happening here is, while front is clear, Karel is executing these commands. Now when the Karel is on the last corner, the front is no longer clear. So before it goes into and executing all these commands, this is false. So Karel exits the while loop without building a column on the last corner. So we have to build a column outside the while loop. Now before we build the column, let's clean up our code. We are building a beeper column here, and then we are going to build a beeper column again here. So we're building a column on the last corner. So we don't want to repeat the code. Now as we learned in part 1, we get around this problem by writing functions. So we say build column, and here we take this whole code and put it here. Now, we do not want to keep the responsibility of checking the beepers here. So, we should keep this in the main code. Here our indentation is not correct. Let us fix that first. This is good. Now, every function we should write some comments. So, the precondition for this building a column is that Karel is facing east. And then build column, then face east again. One more thing that we can clean up here is that we are repeating the code 4 times here. This is definitely 4 times that we have to write the code. So, we use the for loop for I in range. Now, we have to do it, repeat that 4 times. So, we put 4 here and then we take this, okay, and can remove all this code from here. So, we have to build a column, we turn left and then we 4 times we move and put beeper, and then we turn around and move all the way back down and then we turn left to face east. Okay. So, this is the function called build column. We can take this function and put it here. So, if beepers present, build column. Okay. Let us run the program again. Okay. This is working perfectly as before. Now, to take care of the last corner, we call the build column function again here. Okay. We reset, just make it a little faster, run program. So, we have placed beepers on all the corners. Finally, we want Karel to go home. To return home, Karel has to first turn around, then again we have to write while front is clear, move. You do this, Karel will reach all the way to the left corner and then it has to turn around to face east again. Now, we can take this code and create a function called go home. Okay. Now, we need to create a function dev go home, reset, run the program again. Wonderful. So, we have achieved our target state, but there is a bug in the code. What will happen if there isn't any beeper on the last corner? I will leave that as an exercise to you. You can find the solution with the fix in the GitHub repository. In this task, Karel needs to place a beeper at each corner with a missing beeper. We have a world with 6 rows and 5 columns. There is a beeper on some corners while others have none. Here we have a new Python file, fill beepers solution, that loads the initial state, fill beepers start. In this task, there are walls between each row which Karel cannot cross. Karel can move to the other rows only via column 1, which does not have a wall. So, let us decompose the problem first. Task 1 is to move across the row and place beeper on empty corners. Task 2 is to move to the next row above and repeat step number 1. Task 3 is to repeat steps 1 and 2 until all rows are filled. And finally, return home after completing all rows. Go to task number 1. So, for the first task, we know how to move across the row while front is clear, move. Now, we also have to put a beeper. So, let us put beeper. So, here we are going across the row, putting a beeper and moving to the next corner. So, let us run the program. Well, it's working, but we have an issue here. We are putting a beeper where there is already a beeper present. So now here is a case where we first have to check if there is a beeper present, and if it's not there, then only we have to put a beeper on that corner. So we have to use the if condition. So how do we check if there is no beeper? Earlier we used the if beepers present. So here we have to check if there is no beeper. So we have a helper function called if no beepers present and put beeper. Let's reset and run. Okay. So we are good so far. Here we are doing an action which we can convert it into a separate function. So let's take this code and create a function called def check and place beeper. Okay. Now we take this code and put it here. We run it again. Okay. So it's working. The next task is to move to the next row above. Okay. Now before that, Karel has to come back to column 1. Okay. Return to first corner. Okay. So here first Karel has to turn around, then can use while front is clear, move, and then again it has to turn around. Okay. So let's test our code. Okay. So it works. We know that we'll be calling this code multiple times, so let's convert it into a function. And give it a meaningful name. Okay. Let's run it again. Okay, it's working. Next task is to move to the next row above where Karel is facing east. So Karel first has to turn left. It has to move. We want Karel to face east again. So the position will be exactly the same as it was on row 1. And for that, Karel has to turn right. So run it again. Karel will be moving up after filling each row. So we have another candidate to write a function. So we call the function move to next row. And put it here. In step 3, we have to repeat step 1 and 2 again. Now we have to repeat the same process for rows 2, 3, 4 and 5. So I think we should write another function. Now this is step number 1. Let's create a function called def fill row. Now I'm not writing comments here, but in general you should be writing comments to describe what the function does. Bring it here. We fill the row. Set make it a little faster. Run program. Okay, so we are good so far. Now we are repeating steps 1 and 2. Let me simply copy these commands and then we move to the next row. Let's run it. Now we have an issue here. In row 2, in the last corner, Karel did not put a beeper. So there is a bug in the code. Let's see what exactly happened. We have in the fill row, while front is clear, we first check and place beeper and we move. Now on the last corner when Karel is there, the front is clear, returns false, so it will not be executing the commands in the code block. In the row 1, it worked because there was a beeper already present on row 1. But in row 2, there was no beeper and Karel did not put a beeper. So we have to take care of the last corner. Check and place beeper on the last corner. Run it. Okay, so we solved that problem. Now we repeat these 3 more times. Okay, we have to do it one more time. Well, Karel crashed. Now here we are moving to the next row, but there is a wall in the front after the last row number 5. So Karel can't move up. Now before we tackle this problem, let's first see, we are repeating these commands fill row, move to next row 5 times. We can solve this problem using a for loop or a while loop. Let's use while. Now we need a condition. What condition can we use so that Karel can keep moving until there is no more room to go? Now the decision where Karel has to decide whether to move to the next row is on the leftmost column when it moves to the row above. Now if the row above is blocked, then Karel cannot move up. Okay. Now at that point, Karel is facing east, so the wall is on the left of the Karel. So we have to check for if left is clear. So while left is clear, Karel can move up. Can get rid of these commands here. Now since we are writing a while condition, we need to indent the code. Let's run it. This condition where left is clear, it checks for if the left is clear, which is false here. So in that case, we are right that we are not moving up, but we are also not filling the row. So we have to execute another command to fill the row here. And just add a comment, run it. We have completed putting all the beepers. The last task is to return home. So let's write a function, go home. Def go home. From the current position, Karel first has to turn right, then go to the other corner. While front is clear, move, and finally Karel has to turn left. Let's reset, run the program. Perfect. So we finally completed all our tasks and achieved the target state. This completes our lesson for today. We have learned about control flow and how to use statements like if, for, and while loops to write more efficient code. We did all this without using even the basic programming concepts like variables and data structures. I'll be posting a few more videos where I'll solve some other challenging Karel problems. To learn more, you can always register for my Python course on Udemy. Thank you.